how much? From this to this, how much? Do we have any maximum weightage, any minimum weightage? So those actually where you can easily do the partitioning. But if your functionalities or your requirement more to action based, okay, like just now the second pair is under the logic based, right? So for example, okay, if you do this, then this is the effect happen. So for example, if this condition is fulfilled, this is the effect. If this condition is not fulfilled, okay, what is the effect? So when we have logic based or more to action based or fact based, it will not be suitable to use this equivalence partitioning, because we don't have the minimum and the maximum range where we can divide the partitioning. Got it? Can understand? Okay, I really hope online classes is working. I'm a bit worried already, because when we are not seeing and then explaining all this online, it is not helping much. I know. Of course, later in our tutorial, we will do the questions. We have tutorial questions. Okay, so we can see like different scenarios, different like type of information given, and from there we can see how the technique actually suitable for this kind of scenario. This one, how it's suitable to use. Okay, clear? Can I? So later when we meet up for tutorial, we will correct this table, because like what I said, there is also another one more column here, okay, which is for the expected output. So for valid equivalent classes, the expected output will be this discount, okay, this discount. But when it comes to invalid equivalent classes, it will be error messages. Just remember that. Okay, so the continuation of this equivalent partitioning technique, we have boundary value analysis. Okay, so I'm not going very detailed into this, because I want to confirm that all of you are very clear with the first technique first. So I just want to briefly say what is this boundary value means. Okay, so the boundary value here is actually will check the borders value of the equivalent classes. Just now I say, right, these two, they work together. Actually, boundary value analysis can also work on its own. But when we are working on the equivalence partitioning, it must come together with the boundary value analysis, because we want to make sure that each of the border value of the equivalent classes must be correct. Remember, just now we have the minimum value, the maximum value. So we want to make sure that how we break each of this partitioning, it is with the correct maximum value, correct minimum value. There is no skip of any values, and there is no repetition of any values. That's what we want to do by using the following technique, which is the boundary value analysis. So on every border, there must be the exact boundary values and also both nearest values. Okay, so later I will just give you one example. Then after that I will stop, because I will proceed with the tutorial first, then only we will continue more. Okay, so from the classes which we and another one more is boundary value analysis will only work for the valid classes, not for the invalid classes, because we said we want to see the border value, right? So only if we have the minimum and the maximum. That's why I was saying our fourth class we need to have the maximum, because we need this we need the border value from the minimum and the maximum. And if we don't have the minimum and the maximum, we could not identify the border value. So let's assume if I say that it is more than 25,000, and if we did not indicate any maximum value, it means I don't have any maximum value where I will stop. And if we say there is no ending of this maximum value, it means my border value will be infinite. So when we have infinite, how we are going to test that? So that's why we must close the partitioning classes by having a maximum value. See this example which I have referred from the source of book, it's not good because we need to have the maximum value. So when we do our tutorial, when we do our assignment later, we will follow with the maximum value. Okay, because if we don't have the maximum value, we actually cannot have the upper boundary and also the lower boundary for each of the classes, and we don't want that, because if we don't have this upper and the lower boundary, we cannot check if it's a valid value or invalid value. Okay, so let's me show just a simple example here, then after that I will stop. Okay, so this is actually not using the previous example, this is another different example. So if you see, this is actually a text field accepting age. So when we say age, it's actually accepting the value from 18 to 56. Okay, so the minimum age which is accepted here is 18 and the maximum age is 56. So they already give us a valid equivalent class here. Okay, it means we have only one valid equivalent class. So from this valid equivalent class, we want to move it to the boundary value analysis. So for boundary value analysis, we will break it into three: border value or boundary value. If you see, this is invalid, this is invalid, and this is valid. So when we set valid, under the valid, we have minimum value, we have minimum plus 1 value, we have maximum minus 1 value, and maximum. This 4 is considered as 4 valid values for this given partitioning. Okay, got it? If you see, minimum is 18, maximum is 56. So the valid range here is from the minimum to the maximum, and we have maximum minus 1 and we have minimum plus 1. So it means we have 18, 19, 55 and 56. This is 4 valid values within the given range. Then on this side we have invalid, where minimum minus 1. Minimum minus 1 means 17, it is invalid. And here we have invalid, which is maximum plus 1, which is 57. Okay, so from the minimum boundary value of 18 and the maximum boundary value which is 56, we have total of 4 valid data or 4 valid input, and we have 2 invalid input. So that 4 is actually for 4 positive test case and 2 invalid, which is 2 negative test case. So it means from each from each equivalence partitioning, I can make it much more specifically with 6 test case. So just now remember we said 4 test case for the entire equivalent classes and 2 for this entire equivalent classes. So I have 4 positive test case, 4 two in negative test case for this entire function. But from there, I can actually break it 6 test case for each classes by using this boundary value analysis. So it means for these 4 valid equivalent classes, how many total test case I can have? If I have 6 per classes, I can have total of 24 test cases, where each equivalent class I will have 4 positive test case to test 4 valid input, and I can have 2 negative test case to test 2 invalid input. Can understand? That's why we cannot use the 4th class like this, because we need to have the maximum value. Because if we don't have the maximum value, what will happen here? If I follow this one, the minimum value is 25,000, correct? So what will be the minimum here? 25,000. The minimum plus 1 will be 25,001, and the invalid here will be 24999. But what happened to the maximum? I don't have the maximum value. I cannot have the maximum minus 1 value, and I cannot have the maximum plus 1 value. So it means our test case cannot be complete. So the problem will not be faced here. But when we bring this to boundary value analysis, then we will not have the maximum value for our test case preparation. So that's why we need to make sure that every valid equivalent classes must have the minimum and the maximum value. Got it? Can understand how we will transfer the valid equivalent classes to the boundary value analysis? Okay. Can? Okay, so we will stop here. We will stop until the boundary value analysis. I don't want to pressure more. Okay, so we will stop here. Then we will proceed with our tutorial first, so that you can understand better. So during our practical time also, we can do the hands-on for this technique part. Okay, so that it will be helpful later for your assignment and midterm and final exam. Okay, got it? So I did not complete the boundary value analysis yet. So we can try by using this example later. In the class, we will do this again, come up with a proper table, and then from there, we will proceed with the boundary value analysis. Okay, so other than that, all this is just example of different numbers. Okay, got it? Can understand? Okay, any question?
Miss,
Yes.
what was the thing that you talked about in the middle of the class just now? That thing that you said is not very important in the finals one.
It's not important. That is actually the last part of the chapter, not this one yet. The last part, you can see you have the pairwise testing. There is one called pairwise testing. After we will complete with the logic base. So that one is not important. I don't use
Oh, I
that
see.
for.
Okay, okay, okay. Thank
So
you.
we will concentrate on equivalence partitioning, boundary value analysis, and also the cause effect graph decision table under the logic piece. The pairwise is more to UI thing. So I don't do any question much using UI.
Okay.
So that one is just like for us to go through only.
Okay.
Mm.
Thank you, Miss.
Okay. So any question, guys, before we end the session? Okay. So if there is no question, then we can end the session here. Okay. So thank you very much, guys. So I'll see you tomorrow.